All right, let's get some more discovered, explored, learned, whatnot. If this is the first time you watch one of my videos and stuff, these videos are morely about my journey learning C++, what I'm discovering, what I'm learning, not so much me teaching. So if you like the videos, hit the like button. Um, if you have any comments, suggestions, questions, or want to uh, something I say that may be incorrect and you want to correct it, that's perfectly fine. You can leave those all in the comments. Um, to get started right here, first off, uh, we were going through W3 schools. We went through all of that already. We're going to learn CPP.com now to get a more detailed understanding and learning education of C++. On the right side, their website, and on the left side, we have VS Code, a text editor slash IDE for writing code when we're ready to get back into that. There are plenty of examples in here. We just haven't got to them yet. We're just kind of more doing the introduction of this site right here. So learning some history, learning kind of the behind the scenes of how programs run, work, etc. So let's get diving into this. All right. So this is where we left off. We already read through this part right here, which is this is just basically a diagram of how the program might work. Define a problem you want to solve. So you build a program to solve that problem. It could it it could be a problem with not having enough entertainment, so therefore you build a game, or a problem you have in life, so you build a program to help you solve that problem, so forth, so on. Step two would be design a solution for it. Step three would be write a program that implements that solution, so forth and so on. We're going to kind of go through those more in detail here. Step one, defining the problem that you would like to solve. This is what step. This is the what step. And I do read this aloud when I'm doing this and stuff. That way, if anybody kind of wants to join me, it kind of becomes a little bit of a study group, I guess. Anybody else that's learning C++. This is what step, the what step, where you figure out what problem you are intending to solve, coming up with the initial idea for what you would like to, the program, for what you would like to program. You can be the easiest step or the hardest step, but conceptually it's the simplest. And it kind of is the simplest. Coming up with the idea and stuff, if you can come up with just a fragment of an idea, and start typing it in there, and then once you type it in there and stuff, maybe the idea of the comes more and more to you, but then the harder problem would be to actually get the program to do what you want it to do, along with figuring out what's wrong with the program and why it won't do what you want it to do. But yeah, all you need is an idea that can be well defined. You're ready for the next step. Here are a few steps. I want to write a program that will allow me to enter many numbers, then calculate the average. And that's not too difficult, but it's an idea. Maybe it's not numbers, maybe it's people, maybe it's cars, maybe it's price. Um, yeah, so averaging out different things. Um, or you might want to write a program that generates a 2D maze and lets users navigate through it. The user wins if they reach the end. So more of like a kind of a game type thing for entertainment. You can have prizes in it. You could have uh, more of a race in it if you want to, sort of thing. So there's a couple more ideas of what kind of a program you might want to build. Give me just a second. Sorry about that. My throat keeps wanting to dry up. It's still kind of trying to. Third one here, I want to write a program that reads in a file of stock prices and predicts whether the stock will go up or down. Um, that is a program, yes, you can write and stuff, but you're gonna have to do a lot of research on stocks, prices, and how they fluctuate in order to write a program that would predict whether they would go down or not. For example, I know that if it has something to do with corn, but a certain state ends up going through a drought, then that's going to cause the price of corn to fluctuate. Oranges would be the same way. Pretty much any kind of perishable item and stuff that has a stock price to it. Um, if a company invents something new and stuff, their stock prices could go up. So if it's a research company and they come up with an idea that maybe gets a bunch of people to buy a bunch of products from them or whatnot, or a certain product from them, so forth and so on. Anyways, step two, determine how you're going to solve the problem. So this is where we have to come up with the ideas of how to write these programs. And the ideas itself and stuff, yeah, it can sometimes be difficult, but it's probably not the hardest thing. I would say step two is probably the harder thing. Writing the program itself, the research, what you need in the program for it to work. This is the how step, where you determine how you're going to solve the problem you came up with in step one. It is also the step that is most neglected in software development. The crux of the issue is there are too many ways to solve a problem. However, some of these solutions are good and some are bad. Too often, a programmer will get an idea, sit down, and immediately start coding a solution. This is often generates a solution that falls into the bad category. Um, Typically, good solutions have the following characteristics. They are straightforward, not overly complicated or confusing. They are well documented, especially around an assumption being made or limitations. They are built moderately, so parts can be reused or changed later without impacting other parts of the program. They can recover gracefully or give useful error messages when something unexpected happens. When you sit down and start coding right away, you typically think, want it, I want to do something. So you implement the solution to get uh, that gets you there fastest. This can lead to programs that are uh, fatigue, fragile. Sorry, I'm also learning to read a little bit better too. Uh, yes, as I've been doing this, I have increased my ability to read and read faster and stuff. It still has some issues and stuff because a person like me with dyslexia and stuff still struggles to pronounce some words or even read words properly, especially for the way I see them and my mind processes them and then tries to execute what I'm wanting to do. Anyways, this can lead to programs that are fragile, hard to change or extend later, or have lots of bugs. A bug is a kind of programming error that prevents the program from operating correctly. So you get output, but it may not be the correct output. So if it's like trying to predict a stock market and you get an output, you use that output, but then the output was not what was predicted, it could be something to do with the program itself. Not enough research, number of things. As a side, the term bug was first used by Thomas Edison back in the 1870s. However, the term was popularized in the 1940s when engineer found an actual moth stuck in the hardware of an early computer, causing a short circuit. Both the logbook in which the error was reported and the moth are now part of the Smithsonian Museum of American History, and it can be viewed there. So yes, a gentleman, after a computer was built, there was a tapper that was coming down to trigger a signal, like a switch, but there was a moth stuck in that tapper. He found that moth. It took a few hours to find that moth because the computers back then were so massive. You were literally sitting inside the CPU sometimes or the hardware sometimes. Um, Found the moth, put it in his notebook, pinned it to his notebook, or taped it to it, however, and then wrote a little note right there saying first bug ever found on a computer because it was generating incorrect data. But apparently, yes, that notebook, that moth, is in the Smithsonian Museum of American History now. I did not know about that. I'm not even sure what the Smithsonian is, but various studies have shown that on computer software, on complex software systems, only 10 to 40% of programmers' time is actually spent writing the initial program. The other 60 to 90% is spent on maintenance, which is consists of debugging, removing bugs, updates to cope with changes in the environment. Uh, for example, to run a new OS version, yes, when something, yeah, enhancements, minor changes to improve usability and capabilities, or initial improvements to increase reliability and maintainability. Consistently, it's worth your time to spend time, little extra time up front before you start coding, thinking about the best way to tackle a problem. Yes, I have actually mentioned this a few different times, but I'll get to that in just a second. What assumptions you are making and how you might plan for the future in order to save yourself a lot of time and trouble down the road. Uh, and down here it says we'll talk about more of this in the future, but yes, I have mentioned this before. Pen and paper to jot down some notes. I know people may find that completely useless, or use Notepad or something to write down notes. Um, you come up with an idea, have a notepad with you, jot down the idea. You see something that triggers more of an idea or another idea or a thought to go with the current idea, get your notepad out, jot it down. There is probably so many different times when people have been outside and seen things, waterfall, trees, the way people move around a city, city lights, and so forth and so on. And it just triggers an idea, but they don't have anything to write it down. So by the time I get back home, that idea is completely gone. They have forgotten all about that idea. They even forgot what they were thinking about in the moment of that idea. Or if they just had a simple notepad and a pen or pencil and stuff and jotted down the idea when it came up, uh, then they wouldn't have forgot about it. Or the other idea, you have the idea, so the next thing you do, you rush home really quick to try to mark down the idea or implement the idea on what you're doing, and then you miss out on the activities for the rest of the day because of it. Um, I've seen it done many times. I've written down notes for when I used to work on cars all the time, so that it would help out the people that were dealing with the customer in trying to explain what was going on or what happened, or how the problem was solved. That way, the customer or the service writer and stuff could have some sort of an idea, especially even a notepad or whatnot and stuff, to recall when the last time this was done or how it was done or what happened in this situation. That way, the next time the repair needs to be happened or maintenance needs to be done. That's a key thing. People always struggle to try to remember oil changes on cars, rotations for their tires on cars, um, and that sort of stuff. And we actually have notes for that. Sometimes there's a sticker that goes up in the window to indicate it. Sometimes you gotta it's on your receipt, um, so forth and so on, to remind you of these things, because you got so many things going on a daily basis that it's impossible to remember them all. We even have our phones and stuff to remind us of things, or Alexa, or whatever you may have. But yeah. Um, Step 3, write the program. In order to write the program, we need two things. First, we need knowledge of the programming language, which is what we're currently working on now. I don't have enough knowledge myself. That's what these tutorials are for. Second, we need a text editor to write and save our C++ program. The set of C++ instructions we input into the text editor is called the program source code. Often shortened to just code, it's possible to write a program using any text editor you want, even something as simple as Windows Notepad or Linux via or Pico. I've never heard of Pico. I didn't even know that. I guess that's what Linux is, or not Linux. Unix is. Unix via. I guess it's a kind of a notepad thing for probably a different operating system. A program typically, a program typed into a basic tech editor would look something like this. And I do have an example there, which we've seen that example many times. Pretty much just include IOStreams library at the top, the main function, and then just an output with some text, and then a return 0 is all that shows. However, we strongly urge you to use editors that are designed for programming called a code editor or an IDE, which is not actually mentioned. But and again, if you've never heard of it or you don't know what IDE stands for, if I'm not mistaken, I think I read this a few different times, but I'm still struggling to remember it. I believe it's integrated environment, no, integrated development environment. There we go. I think that's what it is. Don't worry if you don't have one of these yet. We'll cover how to get one in a later part of this site. Yeah, which I've covered that a few different times and stuff, but I don't know what kind of system you guys are running on, so it can be kind of different depending on the system. I think this one goes over 2 or 3 different ones in this material, but I'm not sure. A typical editor is designed for coding has a few features that make programming much easier, including line numbers. So all my number lines right here are numbered, so it kind of gives me an idea, uh, especially something to refer back to. Without these right here, I mean, I can still write the code just fine, but if you want to mention to somebody, yeah, it's on that such and such file and stuff, line 45, I believe, sort of thing. That's where that code is. You may need to change that or fix it or adjust it or whatnot. Kind of a reference guide. But yeah, line numbers are useful when the compiler gives us an error. As a typical compiler error will state some error code slash message line 64 without an editor. This shows a line number. Find the 64th line. So if you have an issue and stuff, then yes, sometimes I guess your error messages can indicate which line it is. Normally, this one right here shows me the line of code, not so much the actual number of the line. Number 2, syntax highlighting, which yes, you've seen that on this and stuff. It'll change the colors, especially with the curly brackets, and that can be kind of hard to keep track of which curly bracket belongs to what. Um, so yeah, that's quite helpful. Where my Windows notebook does not color code or number the lines, either one. Anyways, syntax highlighting and coloring changes the color of various parts of the program to make it easier to identify the different components of the program. An unambiguous fixed width font, often called monospace font, non-programming fonts often make it hard to distinguish between the number 0 and the letter 0. In this case, no. You have above this the letter 0, and there's the number 0, which it has a line through it to indicate the difference. Or between the number 1 and the letter L. So the number 1 being this, the letter L being this. Look very close to the same, and in some fonts and stuff, they can be identical to each other and can be difficult to tell where they're both just a straight up and down line. Something else that would go along with that and stuff that may make that a little bit difficult is that right there. So if your one just looks like a line, your other just looks like a line, this just looks like a line, what's the difference between the 3 of them? Well, with the right proper font and stuff, it can make it easier to determine that. Anyways, but also not to mention the uppercase I, but Again, that one's another one that has its own uniqueness to it. Right there it is. So with some fonts and stuff, all four of those can be identical, and you can kind of struggle to determine which one's which. Anyways, a good programming font will ensure these symbols are visually differentiated in order to ensure one isn't accidentally used in place of the other. All code editors should have an enabled by default, but a standard text editor might not. Using a fixed width font, where all symbols have the same width, make it easy to properly format and align your code. Yeah, I know I'm not reading this very good, but it happens. Like I said, you're welcome to go to this website, read it and stuff, and then kind of make comments in the comments right here and stuff, kind of like again, a group study thing to where we help each other out, whatnot, with trying to understand C++ if you're new to C++. So here's an example of C++ program with line numbered syntax highlighting and fixed width font. So this right here shows it, and you know what? This is the first time I'll be able to actually write some code in here, so why not go ahead and throw it in there. So first we have the include IOStream library, the main function, curly brackets for the main function. We just got a standard output with some text. Um, but you can definitely tell the difference between things with the different coloring in it. You got for the type, it's red. For the include, it's a dark purple. For the main function, it's a light purple. For the library, it's blue. For the content, it's blue. You got I think that's a teal for standard. You got the keyword, which is character out for the output right there. Return, which is a dark purple, seems to match the include as well. Numbers are marked in gray or white. That looks kind of like gray, but it may be actually white with the black background, making it look gray. And then the semicolons the same way as the numbers. So uh, note how much easier it is to understand than the non-highlighted version. So non-highlighted version, put that over here for a second. Put this over here. Same thing written out both ways, except for this right here. And we'll zoom in since you can. Oops, my bad, wrong one. Uh, Move this over to here. There we go. Okay, so now you got one that doesn't have any color to it. You got one that has color to it. So if we were to move all this together, oops, and believe me, none of the spacing is even really needed. It's only makes it easier to read. And to move all this one together right here. The only thing I'm missing from this one right here is the return 0. But you see how hard that is to notice? Actually, I think there has to be a space in that right there. Okay, so this one right here is a lot easier to read. I mean, even though it's all put together and everything in one line, one or two lines, it's a lot easier to read because the coded, uh, because it's color coded. In fact, I can go ahead and put this right here together. Not to mention that this text editor right here will show me or indicate if there's any errors in it. Like for example, if I went ahead and took the space out of there, it would indicate an error right there. Um, Not to mention, I'm not sure if this notepad actually saves the same way as what this does. So if I hit the save button, I'm not sure if it would save exactly the same way. I know that there is a process for saving it. I have to go and create a file, save as sort of thing, and then create the file name for it. I'm not going to do that, but yeah, so the color code, I mean, there's a huge difference between these two programs, but both of them are very simple programs. They're just here to allow me to write code into something. This one has the uh, ability to find the compiler. This my notepad does not. I would have to actually add in a path for Notepad to find the compiler to actually compile this and put it into an output, which the output would end up being some sort of window at the time. I would have to run them all in Windows. This one right here has a terminal built into it, so when I run this, I can see the message right there. It's already built into it, but they're still both very simple programs. Anyways, moving on. Um, Note how much, yeah, we've already seen that. Tip, coding, font, and programming fonts both have neat tools that allow you to compare different coding fonts to see which one you like. So that's something else I want to add. Both these have a black screen to it, making it much easier to see the white and the coloring to them. And you can set both of them that way. You can also set both of them to a white screen, but it's easier on my eyes. It's easier on my eyes if I make the background black and the text white, where this right here is actually a lot harder on my eye. Plus, it's actually even a lot harder on the screen. Uh, to put all this white in here and stuff, it causes the screen to get a little hotter. Most screens you don't have to worry about that too much, but if you are out there investing in a 4K screen, the 4K screens do get hot, do get warm. That's why they have a maintenance package to them. I doubt that anybody has an 8K screen because I know those things would get extremely hot. I know right now those are in development and they're trying to work on trying to get it to where they'll stay cool better. My screen and stuff, when it does get hot, I can hear the plastic kind of creaking around a little bit because of it flexing back and forth a little bit. Um, I believe that the old screens are also made out of plastic morely because it's cheaper, so it makes the screens easier to purchase or cheaper to purchase. But with the 4K and the 8K, they can't do that. They can't make the screens plastic. It actually has to be glass because glass does not flex. So therefore, the screen will not actually shift when the screen gets hot. Plastic will. Um, in fact, I got two screens here. One of them is a cheap Dell screen. It is mostly made of plastic. In fact, the screen is plastic itself. The other one is a MSI version screen, a much more expensive screen, but the screen is glass, and it's glass because of the heat. So it's also got quite a few heat sinks in it and stuff to keep it from getting too hot, to allow the air to, uh, or the heat to be pulled away from it. So, but yes, the whole idea and stuff is the fact that you can change the background and makes it easier on your eyes, make it easier to tell the difference between everything. Anyways, moving on. For advanced readers, because source code is written in as ASCII characters, programs languages use a certain amount of ASCII art to represent mathematical concepts. For example, the not assigned to is not part of the ASCII character set, so programming languages typically use the exclamation mark equal sign to represent mathematical inequalities instead. Um, so I know you probably can't see that, so and I can't make that character on this. I don't know how, but there is a such character as an equal sign with a slash through it. It would have that kind of a slash through it right there. So those two combined, not together, but as one symbol. Um, but since you can't put that into C++ code, what we use instead is this right here, which indicates the same thing. The exclamation mark actually indicates not. And then with the equal sign there, it's not set to. Um, I'm not sure why the other symbol's not in here. Probably because it's not on the keyboard, and it just makes it a lot easier to type it that way since it's not actually on the keyboard. It may be on some keyboard, but it's not on mine. So you can maybe make a macro for it or something like that to where that'll work. But either way, moving on. Some programming fonts such as Fira Code use literals to combine such art back to a single character. For example, instead of displaying the not not assigned to one, fire code will actually display the equal sign with a slash to it. Um, don't have any experience with that, so I don't know anything about that. But then there's something here in parentheses using the same width as the two character versions. Some people find it easier to read. Others prefer sticking to more literal interpretations of the underlying characters. So yes, you may be able to put that in there, but it doesn't mean the next person working on code, on your code, or on code that you guys are sharing and trying to come together as a group to build a program, doesn't mean that everybody in that group is going to understand that character or be able to use that character. Um, so even though you can, because you're using a certain thing, doesn't mean everybody can. Um, so keep that in mind with your code and stuff when you write code. If you're writing it in a group and stuff, then you kind of need to inherit the way everybody else writes it, and come together with a compromising way of writing the code. That way, everybody can contribute to it the same way. Moving on, many simple C++ programs only have one source code file, but complex C++ programs can have hundreds or even thousands of source code. So even though this right here is only one program that I've written, this right here actually has several files to it. So when I write a program with this right here in it, even though this one may be only one file right there, this right here, because of it being in there, actually makes it to where this is multiple files. Um, and what I mean by that, so if I open up my file thing here and go to the actual location of this file, uh, so go into the actual location. This is the executable file. This is the exe right here. The practice.exe is the bottom one that says application. I know you can't probably see that very well, but yes, it is currently 134 kilobytes. The program I wrote right here, this by itself, is literally only 1 kilobyte. It's not until I execute the code and it starts including the library, then the application becomes 100 times larger because it's including so many more files. So the program I wrote is only 1 kilobyte, but in order for it to work properly, it has to include all the files with IO streams, which is another 133 kilobytes worth of data. So, anyways, moving on. Let's see, requires for, trying to remember where it was. Okay, yeah. Each source code file in your program will need to be saved to disk, which means each source code file needs a file name. C++ does not have any requirements for file names. However, the de facto standard is to name the first slash primary source file created for the program main.cpp. So yes, you normally have a main.cpp or an index.cpp and then maybe a project.cpp, basically indicating what's in the file itself, just like you would describe a variable, what the variable value is. The file name main makes it easy to determine which is the primary source code file, and the CPP extension indicates that the file is a C++ source file. So yeah, if you have, you can end up having another one called main.js or main.py for JavaScript, for Python, which is the main source for that Python file or Python project. So yeah, just more than one way to indicate descriptive words for your files. And that's actually why mine is labeled practice, because this is what I use to practice with. I write code in here, I practice with it, I mess it up, I get it right, I experiment with it, practice with it over and over and over to get better at it. And I still need a lot more practice. Moving on, you may occasionally see the first primary source code file name after the name of the program instead. For example, calculator CPP. So if you're writing a calculator program, app, etc., you might name it calculator, and then have something else marked as main or something. I don't know. There's a variety of different ways you can describe your file and stuff, especially if you want somebody else it did take me a while to realize this. So when I wrote a program, I was going to here. And I thought that clicking on this would cause the window to open up so I could actually see it. And no, I was wrong. I have to actually click on this one right here in order to see it. This cannot be opened up in this right here because it's, yeah. Um, but then I was like, okay, well, it's still not opening. Sorry. Anyways, but yeah, it's still not opening. And it took me a while to figure out how to get it to open up and stay open. It's the idea that once the program is done running, it'll automatically close up. So you just basically see a flash on your screen. If you want it to stay open, then you probably should have it set up to where it's waiting on a response from a user. That way the program stays running and you can actually see the program in another window. We'll get to that later on. You may occasionally see the extension used .cc or .cxx. I don't know what those would indicate. I've never seen those before. Best practice, name the first and primary source code of your file, either main or the descriptive word of it. Then this makes it easy to determine which source code file is the primary one. If you have a launcher and stuff, the launcher may be called calculator, where the main everything sits is in the main CPP. But again, we will cover more of that later on and stuff when we actually start working on projects. Once you've written your program, the next step is to convert the source code into something that can be run and then see whether it works. We'll discuss these in later chapters. Moving on to the next section of this right here. So, introduction to compilers, linkers, and libraries. So again, I'm going to go ahead and stop the video there to kind of summarize this. So far we have gotten into what goes on, that there are things that go on behind the scenes even when you're creating a program that you may or may not know about. Whether it's compilers, linkers, libraries, uh, interpreters, etc., whatever, that you just don't see. I mean, that happens with everything. Even as humans and stuff, we cover things up on our bodies and stuff that we don't want other people to see because we may be embarrassed by it, we don't like it ourselves, so forth and so on. We've gone through the history a little bit of C++. We've gone through a little bit of the steps you can take to write your programs. And yes, this does continue on. So we've only covered the first 3 steps, and the next part right here will cover step 4 and etc. Um, But like I said, I'm going to go ahead and end the video with this. Again, like I've said before, if you like the video, click the like button. If you want to leave comments, you're welcome to leave comments. May not always get to them, but I try. This is more about me discovering and learning C++ than anything else. I'm not trying to educate anybody else on it, but if you want to follow along and throw some comments in there, you're welcome to. Uh, so I think I'll end the video right there, and I will see you in the next one.